Okay, guys, today we're gonna discuss about all what you need to know about the derivatives, okay, or differentiation. Susah ngomong. Okay, so it is consists of 3 chapters. First chapter is about the rules. Second chapter is about the use, and third chapter is about the further differentiation. Okay, but I will make it compact. First thing first, all the rules that is consist on every part of the book. So rule of differentiation, first thing first, y differentiated becomes y accent, or fx differentiated becomes f accent x, or uh, or wait equal to dy dx. Okay, that's the rule of differentiation or the basic concept. Now we go to the rules. Rule number 1. When I have y equals a times x to the power of n, so the differentiation value or dy dx equals to a times, you derive the x, so the power become going down, and then x power n minus 1. Okay. Now rule number 2. So this is the scalar rule or the regular rule. Subtraction and division. Y equals, I have any kind of values. A times x power n plus minus, right? B times x power m plus minus blah blah blah. So the dy dx or y accent or the gradient, right? Or the tangent, gradient of the tangent will equals to, as usual, you just do uh, the same over with this, the first rule. B times m, x power m subtract 1, plus minus with the other differentiation product. Okay, now let's go to rule number 3. The multiplication rule. If I have y equals a function times by the other function, so the y accent will equals to u accent v plus u v accent. Accent means the derivative of a certain function, of the first function, and the v accent is the derivative of the second function. Rule number 4, the multiplication rule. Okay. Yes, rule number 4, the multiplication, the division rule, I mean, the quotient rule, u over v. If this is u over v, the y accent, you need to memorize u first. U first. That's the simple way to understand. U first. U first to be derived. U accent v subtract u v accent over v squared. The fifth rule, chain rule. If I have y equals u to the power of n, u is a function, again, u and v as a function. So the y accent or the dy dx, I use two symbols, right? And it's anyway, it's the same. N times u to the power of n subtract 1 as usual, see? As usual. But you have to add one more extra, times by the u accent. Okay, so this is the basic. I will separate this with this because this is on chapter 1. And I give you another 6th rule, 7th rule, 8th rule, and so on. Okay, now this is the basic. I will give you the green color. This will be the basics. Basic rules. Wait. Basic. Wait. I think this is better. Basic rules. And name it one by one to make it easy. So this is a regular. This will be the addition and subtraction. And then this will be the multiplication rule. And this will be the quotient rule. This is the power rule or chain rule. And go next. Rule number 6. Oh, what is rule number 6? Trigonometric rule, right? Sine, if y equals sine x, the y-axis will be cos x, right? And then moreover, rule number, next rule in 6.1, for example, this is 6.2. Oh, wait. Yeah, 6.2. If y equals cos x, the y-axis equals to negative sine x, right? And 6.3, if the y equals tan x, the y-axis will be secant square x. And rule 7, the further trigonometric value. Rule 7.1. If I have y equals sine u, okay, so the y-axis will equals to cos u, you multiply with the inside. Okay, another chain, trigonometric chain rule. Okay, 7.2. If I have y equals cos u, it's very simple, right? Negative sine u, you multiply by the inside, the chain rule. 7.3. If I have y equals tan u, the y-axis will equals to secant square u, you multiply by the inside. Okay, that's the further trigonometric. Are there any further trigonometric? Yes, we have. For example, I have y equals, there you go. I just use the general rule because it's too much to write it down. Y equals trig power n of u of a function. You need, or better, I just write the examples here. Sine cube, for example, sine power n of u. I don't want to give you an example in this part because this will be the whole talking about the rules or the formula. Y-axis will equals to, this is n, right? So the power is going down. Sorry, n times sine n minus 1 to the power of u times by the sine. Wait, I don't have enough space here. I think we need to put it on the bottom of the workings. There you go. So extra. If I have y equals sine to the power of n of a function, so the y-axis will equals to, you put n down, first chain rule, remember this, the double chain rule, n minus 1 time of u, we multiply by the sine, the trigonometric value, cos u, don't put n anymore, and then you multiply by the inside, okay, by the angle. So if I want to make a name, so this is the power, regular power, a regular rule, and this will be the trigonometric rule, chain 1, yeah, this will be the chain 2, or the inside, or the angle, okay, and it has to be applied also in cos and time, applied on cos and tan also. Okay, that's the workings, or this is the extra. And now we're gonna do the next, the learn logarithmic function and also an exponential function. Logarithmic function, rule number 8. If I have y ln x, so the y-axis will be 1 over x. Okay, 8.1. Now 8.2. If I have y equals ln to the power of ln u of a function, keep in mind, so the y-axis will equals to 1 over u chain rule multiplied by the u-axis, right? And then what else? What else? What else? Nothing more. Okay, 9.1. Now we do the exponential function. So let's say y equals e to the power of x. The dy dx, I write one more time, dy dx. I am too much using y-axis, but it's the same, by the way. E power x, you don't have to change anything about this. It doesn't change because it's a natural number. And if I have another y equals e to the power of fx, or to the power of u, a function, so the dy dx is still the same, but you cannot forget to multiply by the inside. Okay, this is the rule that you need to know for every chapter that we already did on previous 15 meetings, right? 5 meetings, 5 meetings, 5 meetings for each chapter. No, I think it's 12, 13 meetings. Okay, and let's go to the application right now. So I don't have enough space right now. So this is the total or the whole rule that you need to understand. Name it. So this is further rules. This is trigonometric rules, right? Okay. And then there you go. Further trigonometric rules. And this will be natural number and logarithmic rules. Okay. Good. There you go. And then what is this? Natural or logarithmic rule. And this will be exponential rule, exponent rule. E is exponent or natural number. Okay. Or natural rule. Okay. That's it. Now we go further for the word problems or for the use of this differentiation. Okay, I will copy this. My computer is getting better because I just clean up the computer and it go back to its performance. Now, let's go to the next part, the tangent and the normal. There you go. That's the first thing of the word problems. Okay, equation of tangent and normal. If you want to see, if you want to know what is the tangent, what is the normal, tangent is always the first derivative. Okay, so tangent line is empty, and it has to be done with the y-axis, the first derivative. Okay, and the normal line can be written as mn, m of n, that has to be negative 1 over mt. Okay, negative 1 over mt, because this is the negative reciprocal and it has to be 90 degree, right, or perpendicular. Negative reciprocal. Okay, that's the first use of the equation of the normal. And next we do the rate of change. Okay, now the next word problem is talking about rate of change. What is rate of change? Rate of change is something that talking about instantaneous value at a certain time. So when we are talking about the rate of change, you are finding the y as dy over dt on time. But I don't think we need too much understanding about this, because the question is quite giving you the simple understanding. Okay, after we do the rate of change, the most favorite part is the higher derivatives here. So let me show you what is higher derivatives. So higher derivative, you go to the further derivative. Okay, higher derivative or higher differentiation. So it is talking about the second derivative, right? And higher derivative is talking about two things. The first derivative and what does it means, right? So, so the first derivative is talking about the maximum minimum point, right? Or the stationary point. Stationary point is where the first derivative equals to 0. Okay, and the second derivative is talking about the nature of the stationary point. We know that stationary point has 3 parts, right? First thing, we have the maximum point, we have the minimum point, and what is it? Minimum point, and we have the inflection point. Okay. So on the second derivative, we are talking about what kind of the stationary point it is. Okay. It is about the nature of the stationary point. So further, right, higher or further derivative. Stationary point. So when the second derivative is less than 0 or negative, it is a maximum point. When the second derivative is equals to 0, it is an inflection point. And lastly, if the second derivative is more than 0, it is minimum point. Okay, that's the rule, or that's what we already discussed previously. For the question, I will give you later. Why? Because we are talking about pure formula. Okay. Oh yeah, the second derivative can be written as like this: y xn d square y over dx square, or f double xn x. Okay, that's the rule. Now let's go to the next part. Minimum and maximum value, and the word problems can be done. I don't have the formula for word problems especially, but it's on the workings later on. Okay, wait. Oh yeah, trigonometric further. How I will give you an example of how a general example about how you derive this. Okay, how do you derive this? First thing first, we don't have the rules of the second. What we have is only sine, cos, and tan, right? So you need to combine, you need to meet, to what you call, to find the integration or to integrate between the second, the trigonometric, with the other rules. Here, we have this only become cos minus sine and second square, right? Only this that we know. How about to derive the second square, second x? You just change it. You know the rule. Second is 1 over cos. Got it? Or you can write cos minus 1 of x. Or you can just write, oh, we already have this formula, right? So the y-axis, oh, we have the power. So put the power first. So the power, as usual, the regular rule, cos minus 1 minus 2 of x times by the cos itself. Cos becomes negative sine, right? And then times by the inside 1, right? There you go. So minus 1 times minus sine, okay, just write it down, minus sine x times cos minus 2x, right? Or if you want to do further, minus sine x over cos square x. The negative is annihilated because it's moving from the numerator to its denominator. Or if you want to go further, you can just write like this: over cos x times 1 over cos x, right? So negative tan x times second x. No problem. Okay, it's quite simple. No, it's not simple. It's quite, you just stick to the rules in order to solve this kind of hard question. This is a simple question, right? But it has to be done with the some rules. First rule is the basic trick, not the derivative rule. Okay, basic trigonometric rule. And then this will be changing to the power rule, or an exponent or indices. We learn it from the previous year or previous semester. And then this will be starting to derivative rule, the chain rule. After the chain rule, you use the simple expansion rule, right? So this is simplifying rule, factorizing. You factorize. And after you factorize, you go back to its basic trigonometric rule. Okay. And you need to do it well. Okay. How about this? Oh, what on earth is this? How can you derive this? Again, you have to do it super slowly. Learn first. That's the first priority, right? So the y action equals to learn becomes 1 over, right? Sine power 4, 3x squared, and you multiply by the inside, right? So what is the problem here? The real deal is on this part, the inside. So when you try to derive the inside, I use the other color to make it more clearly different. So okay, the power first, as usual, right? The power rule, 4 times sine 4 power 1, 4 minus 1 is 3, and 3x squared, close the bracket, and multiply by the trigonometric value. Sine becomes cos. Don't put the 4 anymore because it's pure the trigonometric rule. 3x squared, and you times by the inside, 6x, right? Done. And then what you can do now is try to put everything in order and to make it more simple. 4 times 6x can be multiplied, so 24x sine cube 3x squared times cos 3x squared over sine power 4 3x squared. Now you can cross the sign on top and on the bottom. Okay, so it will become 24. You can cross this, become one left in on bottom, on the denominator, I mean 24x times cos 3x squared over sine 3x squared. And we know that the rule of cos over sine is cotangent, right? So you can make it further, 24x times cotangent 3x squared. Done. This is the final answer. And this will be what you're gonna learn for what you're gonna be given in the question of exams, in exam questions. Okay, and all what you need to do is try to understand all the concepts of the topic. Okay. Examples, I will give you this example, so I will separate the copy paste here, the file, the picture, I mean. There you go. What else? Yeah, so that's all for the topic, I mean for the idea. So I will stop the recording and we will go to the further examples.